Hi, Advanced Algebra 2. We are going to do the notes for 3.1 today. So 3.1 is about solving systems of, just solving systems using tables and graphs. Okay. So first off, we're going to start by solving the system of equations using graphing. We're going to mentally check our answers and then describe the type of lines. Okay. So we have this first system of equations with number 1. Since we're going to graph them, I want to first get them in slope-intercept form. So for the first one, I'm going to divide by 2, so I end up with y equals 1/2 x. Okay, the second one, I'm going to subtract 2x to the other side. And then divide by -1, so my signs all flip. Okay. So we've got y equals 1/2 x, y equals 2x minus 6. I'm going to go ahead and graph those on here. So I'm just down one here. Sorry. Okay, so I'm starting at -6, and I'm just going to go up 2 over 1 using my slope. I'm going to do it quite a few times just so I get a nice line on there so that I can find, if we're solving a system that's answering the question of where do the lines intersect. Okay, that's what the solution is the intersection line. So I want to have a lot of points out here so I know exactly where it is. I'm not off. Y equals 1/2 x. I'm starting actually at 0, so 0, 0. And I'm going up 1 over 2, up 1 over 2. So there, I get my nice intersection point. Okay, so we're going to want to label that coordinate where they intersect is 4, 2. Okay, what I would like you to see if you can do is you can use your graphing calculator in order to check this. And so what we're going to do is enter 2 lines in the graphing calculator, 1/2 x and our other line 2x minus 6. Okay, so go to your y equals. Your first one, you're going to enter 1 divided by 2x. And then y2, you're going to enter 2x minus 6. You're going to check your window, and you can just go, in this case, to like Zoom Standard, which is Zoom 6. Okay, and it should pull up your graph, so you should see the 2 lines that look just like what we have here. And then to find the intersection points, you can hit second trace, okay, which is up there in those commands right next to graph. So second traced. Number 5 is intersect. Okay, so your little cursor is going to come up on one of these lines. So you hit enter, and then it's going to jump to the other line. You hit enter, and then it says guess. You just hit enter again, and it should come up with your coordinate of 4, 2. Okay, I'm going to show you when I'm in class how to do it through a table, so we'll just leave that. So our solution is 4, 2. And how we're going to classify this is, and this is a little bit new for you, so this is going to be consistent / independent. Okay, we're going to go through this table right below of how to classify all those. So this is how we classify this, where basically you have one intersection point. It's called consistent independent. All right, number 2. We have the second equation already in slope-intercept form. The first equation I need to get into slope-intercept form. Oops, sorry. So just down here, I'm going to subtract 6x. Divide by -8. Okay, so -6 over -8, we can reduce that to 3/4 x, and we get +3. So here was our second equation. When we simplify the first one, do we notice something? They're the same. Okay, so if we graph this, we're going to go up up 3, and my slope is up 3 over 4. Okay, so I'm going to kind of run out of room if I go. It's like up here a little bit. I can do it 1, 2, 3. 1, 2. It's up here. I can also go down this way. So 1, 2, 3. 1, 2, 3. Okay. So we get this nice little line on here. Okay. And if we draw the other one, it's just going to be right on top of it. It's the same line. So what we want to look at is how many intersection points do we have? In the first one, we had 1. It crosses exactly 1 point. In this one, how many intersection points do we have? We have an infinite number because any point on this line is obviously on both lines. So our solution for our x comma y is just the line. Okay, oops, sorry, those should be dots. So y equals 3/4 x plus 3. Anything on that line is a solution. Okay, so there's infinitely many solutions. Okay, because the line goes on forever, so there's infinitely many solutions. And if we're going to classify this, we're going to classify it, it's called consistent and dependent. Okay, so consistent and dependent. And we're going to go through this table on exactly what these mean. Okay. All right, and then for our line number 3, we're going to solve and get these in slope-intercept form. So the first one, I just have to subtract 5. Okay, so that's equation number 1 here. Equation number 2, I'm going to subtract 4x. And then divide by -2. Okay, so here's first equation, second equation. Okay. Okay, so we should notice something about these. Do we notice the slopes here? They're the same. So they're not the same line though, because we have different y-intercepts. So when we graph these, we graph the first one, we're starting down at -5, and my slope is up 2 over 1. Okay, so there's my first one. And then the second one, we're going to start at -2 for our intercept. And our slope is again up 2 over 1. 2 over 1. So these lines are parallel. Okay, if I could draw them correctly. They will never intersect. So our solution here is, there is no solution. Well, it's just like the empty set because, there we go. There's no solution. So the solution is the intersection point. They're never going to intersect, so there's no solution. Okay, because they're parallel. And so how we classify that, that is called inconsistent. Okay, inconsistent. So did you notice consistent is where we had an intersection point, whether we had 1 point or we had infinitely many. Consistent is when there's an intersection point. Inconsistent and when is when there is no intersection point. Okay. Okay, so now we're going to look at there are 3 possible solution sets for a system of 2 equations. Okay, so the first possibility is, that we saw was intersecting lines. Okay, so intersecting lines, that means they intersect one point. So just draw two lines that intersect at one point. Okay, one intersection point. So how many solutions do we see here? We call this exactly one. There's one point where they intersect. Okay, and so our classification we saw above, this is called consistent. Okay, because there is an intersection point. And this is also independent. Okay, what happens algebraically? What can we do? This is if you're solving for them rather than solving by graphing. Because by graphing you just see they intersect at one point. If you're solving algebraically, you solve for one variable and then solve for the other. So usually you end up solving for one, find that, substitute it back in, and solve for the other one. So you have two x's and a y. All right, number two, the one that we saw above, this was they were the same line. Okay, so this is also, you could also say they coincide. Oops, sorry, it didn't come out right. There we go. Okay, so same line, they're just the same line on top of each other. So how many intersection points do they have if they're the same line? They have infinitely many. So they do have an intersection point, so that is called consistent. But this is also called dependent. Okay, so it's consistent because there is a solution, there is an intersection point, but there's infinitely many, so it's called dependent. Okay, and what happens when we're solving these algebraically? When we see this, if we're not just looking at it graphically, what's going to happen is both variables are going to cancel out. Okay, so your x's and your y's both eliminate, and you get a true statement. Okay, so a true statement, for example, you end up with like negative 24 equals negative 24. Okay, so that's true. It's equal. So that means that they're going to be the same line. Okay. All right, the last thing that we saw was parallel lines. Okay, so on our graph, just draw a set of parallel lines. So how many solutions did we see here? Well, if they never intersect, they're not going to have a solution, so we have no solution. And so how we classify that, consistent is that there is an intersection point, inconsistent it means that they don't intersect. There is no solution, okay, so they're inconsistent. When we solve this algebraically, what's going to happen is that both variables are going to cancel out. But what happens, the difference with the same line, both variables canceled out, we got a true statement. So we end up with something equals something, and that's true, like negative 24 equals negative 24. What we're going to have here is we end up with a false statement. Okay, so for example, we end up with something like 10 equals 4. Well, that's not true. Okay, so there's going to be no solution here. No matter what x and y we put in, we're going to come out with a false statement. So there's no intersection point. Okay, so that's our classification. All right, so this next example, classify a system without graphing. Okay, without graphing, here's the system. We have two equations. Is it consistent independent, consistent dependent, or inconsistent? Okay, so in a problem like this, what you have to be able to do is you need to both, first of all, tell if their slopes are the same or not. Okay, if they're the same, they're either going to be the same line or they're going to be parallel. So you got to watch out for that. So that's what we need to tell first off. So write each equation in slope-intercept form. So we can look at, well, I'm just going to label them 1 and 2 so that we can keep track of what we're looking at. So number 1, I'm going to add 3x to the other side. Okay, that's all we have to do for that one. For number 2, I'm going to subtract x. Okay, and then we need to multiply by -3 to both sides. Okay, so I end up with y equals 3x plus 4, y equals 3x minus 3. Okay, so we want to watch out. What do we notice about these? Same slope. Okay, but are they the same line? No. Okay, they have different intercepts, so that means they're going to be parallel. We got parallel lines, which means that how we classify them is that they're going to be inconsistent. Okay. So what you want to look out, if the slopes are the same and the y-intercepts are the same, then it's the same line. Okay, so that's what we're looking at. So it's called consistent dependent. If the slopes are the same and the y-intercepts are different, then it's called inconsistent. Okay, slopes are the same, but our y-intercepts different means they're parallel. Okay, that's what we have. If the slopes are different, then they're going to be consistent independent. So this, they're going to intersect somewhere. We just have to find it. Okay, they're going to intersect at one point. This, what we just saw was that they're parallel. So that's what those three options are. Okay, so what we have based off this, what we determined, therefore the system is inconsistent. Okay, that's what we get. So the system of equations is parallel and inconsistent. Thanks you guys so much.